Hey everybody, this is Coach Hammock coming to you from beautiful Georgetown, Texas here in room 122. Hoping you're having a good day. On this presentation, on this video, my pen on my thing just absolutely died. So I'm just going to go through the PowerPoint that comes with this chapter and add some stuff as we go through. All right, so just pay attention to what's going on. Some of you may like this more than my writing. It'll at least be easier to read. Okay, so here we go. Basically, guys, we're still working with exponents. We're going to rewrite expressions involving rationals and rational exponents and then solve some. Okay? I'm going to get to all this vocabulary here in a second. Okay. For any non-negative real number, b to the 1/2 equals the square root of b. So basically what we're looking at now is we're looking at variables that are going to have a fraction as an exponent, okay? If it's a 1/2 right there, all it is the square root of a number, okay? So 38 to the 1/2 power, all right, 38 raised to the 1/2 is just the square root of 38. So let's go through this. 81 to the 1/2. Well, we're going to rewrite it as square root of 81. Square root of 81, which you should know, and you'll have a device on your desk that will help you. If you don't, that's 9. Okay? All right, so if it's to the 1/2, that's pretty easy right there. All right, let's keep going. Square root of 38. All right, well, I can rewrite that as 38 to the 1/2. That's the definition of what we just did. So if you see a square root, it's just 38 to the 1/2 power. All right, that's just going back and forth from what we did before. All right, so 12m to the 1/2. Now, I want you to think about PEMDAS, parentheses, exponents next, then multiply. So what is that 12 acting on? What is the 1/2 acting on? Is it acting on the m or is it acting on the 12m? Well, really, it's just acting on the m. That's the only one it's connected to. The coefficient is by itself out there. So it's going to be 12 times the square root of m. All right, so let's look at this. 32w. Now, this one's a little bit different from the one we just had where the coefficient wasn't acted on by the exponent. But here, because it's under the radicand, yes, that's the word for it, radicand, you've got to put it in parentheses to show that that 1/2 is acting on the w and it's acting on the 32 right there. All right. So here you go. Write this in radical form, 16 to the 1/2 power. Well, I know what you're thinking right now. You're thinking there's not a square root sign. Well, let's think about it. If we go square root of 16, that's going to be 4, right? Because we can simplify that down. And you want to simplify it down as far as you can. Okay? All right, so right here, let's read the Mathanese. For any real numbers a and b and any positive integer n, if a to the n equals b, then a is the nth root of b. What in the world does that say? Well, it means this. Because 2 to the 4th power equals 16, then the 4th root of 16 is 2, or 2 times 2 times 2 times 2. All right? That's basically the book's Mathanese way of presenting cubed roots, 4th roots, 5th roots, all that kind of stuff. And yes, I will teach you in class how to do that on your calculator. All right? So you don't have to know that the 4th root of 16 is 2. I will help you out with that. Okay? So we're going to simplify this. The 4th root of 256. So we're trying to find a number that multiplies by itself 4 times to give me 256. Well, 4 times 4 times 4 times 4 gives you 256. So our answer is 4. All right. 6th root of 15,625. Now, one thing I want you to realize, when you start multiplying a number by itself 6 times, 4 times, that number is going to get big quick. All right. So you multiply 5 together 6 times, and you come up with 15,625. So our answer right here is 5. Okay. Simplify this. I'm just going to go ahead and show you it's 7. All right. And again, there's really not a good way of doing this other than your calculator, and thank goodness that we get to use the calculator on our semester tests. All right. So before we had like 8 to the 1/2 power. What if we don't have a 1/2? What if we have a 1/3? Here's the deal, guys. The denominator will show you what root it is. Okay? So in this one, we have a denominator of 3. And so our root is going to be a cubed root of 8. All right? Here we go. 1,331 to the 1/3 power. So I see a 3 in the denominator. I know that it's going to be a cubed root right there. Okay? So what are 3 numbers, the 3 of the same number, that multiply together to give me that? And the answer is going to be 11. Okay? Simplify this. 2401 raised to the 1/4 power. So right now you're looking at the fraction, you're going, okay, there's a 4, so I know it's going to be to the 4th root. Multiply it out, there you go. Okay, I don't know why it says that, that's wrong. All right, here we go. Simplify this. Going through it right there, kind of quick for you. Okay, here we go. So now, the next step, we had 1/3. What if we have 2/3? Okay, so basically the denominator is what root we have. The numerator is what power we're going to raise everything to once we figure out this part. Okay, here we go. 32 to the 2/5 power. Denominator is our root. Numerator is what power are we raising that answer to. So 5 is our root raised to the 2nd power right there. So what would be the 5th root of 32? Well, it's 2. All right, 2 times 2 times 2 times 2 times 2. And then 2 squared is going to be 4. All right, so your answer is 4. Simplify this. I'm going to give you a little bit of time to try this one. Here's a hint. It's to the square root. It's raised to the 5th power. Okay, so the square root of 81 should be 9. 9 raised to the 5th power is a big old number, 59049, right there. All right, so we're going to simplify this. I'm going to give you a few seconds, work on this one. Okay, you should have known that the square root of 36 is 6, and then 6 times 6 times 6 is 216. All right, moving on. Power properties. Okay, here we go. So if this is where we're going to start to solve for variables in the exponents. The whole key of doing this is you have to get the base to be the same. See how the 5 and the 5 are the same right here? That means that we can solve, we can just make x equal to 3. Okay? X would be equal to 3. Okay, so here we go. We're going to solve 9x equals 729. Now, I could just start putting numbers in here and trying to figure out what it is, but I could also factor this out and figure out, okay, 9 to the what power equals 729? And that's going to be 9 to the 3rd power, okay? 9 times 9 times 9 is 729. So now what I'm going to do is I'm going to get rid of these 9s because the bases are the same, and just say that x equals 3, right like that. Okay, and now you know it's going to get more difficult than that. So here we go. 16 to the 2x minus 1 equals 8. Holy smokes. Okay, can I factor an 8 to give me a 16 base? No. Can I factor a 16 to give me an 8 base? No, I can't, because remember, it's got to be a number times itself. I can't just divide by 2 and throw a 2 up there. All right? But what I have to do is this. I have to factor it to a 2. Factor this one to a 2. 2 to the third power is 8. 2 to the fourth power is this 16 right there. All right? So now we're going to rewrite this, and what they did is they distributed this exponent to the 2x minus 1. So 4 times 2x is 8x. 4 times negative 1 is negative 4. Now that we have our bases the same, we're able to just have the equation 8x minus 4 equals 3. And now, just like our warm-ups that we've been doing for days and days and days, it's a simple two-step problem to figure out that x equals 7 over 8. All right? Yes, I know it is incredibly difficult to get this. And yes, we are going to do 500 problems of practice to understand how to factor these down to the correct number. Okay? All right, I'm going to leave this one up for a second. I think you probably have to factor this one down. Just a hunch. Just a hunch. All right, so if you work this out and if you factored it down, you came up with 5/3 as your answer. 5/3. We'll go over that one in class and figure out where you factor it down and how we get to that answer. Okay? All right. We're going to skip this part real quick. Going through, ba-ba-da-ba-ba-da-ba. And that's it, guys. All right? I know that you're going to have a lot of questions. Don't get caught up in specifics yet. We're going to go over it as soon as you get to class on Friday. And we'll make sure that you have a great understanding of this before you leave class on Friday. All right? Keep your heads up. We've got this thing. See you in class.